Hello, I'm Dr. Tom King, and I'm the Medical Director of Immunovia Inc.'s state-of-the-art laboratory in Marlborough, Massachusetts. I'd like to welcome you into the laboratory today to give you an introduction in terms of how we perform the IMMray PanCan-d test for the detection of pancreatic cancer in its early stages. The first step that Janet is performing here is receiving samples in our custom shippers, which maintain a constant 4-degree temperature to preserve samples. She's checking the temperature as it arrives there and will now move on with the specimens on ice to begin accessioning the specimens into our custom computer system. She's also inspecting the samples to make sure that they are of adequate quality and that all of the patient information matches. Once she's completed that, she will box the samples, which are received in duplicate or triplicate, for the next steps in testing. And she'll next hand those off to Hannah, who will perform the CA19-9 test using the Roche Cobas instrument, which you can see here. She's now pipetting those into cuvettes, loading the rack, and the samples will be automatically analyzed in this instrument. In parallel, Alexis is now performing the biotinylation step of the LDT. She's adding human serum samples to a microtiter plate, along with reagents, including a biotinylation reagent. She will then move the sample to a rocker in the refrigerator to allow the biotinylation process to continue. Here she's sealing the top of the plate to prevent evaporation, removing it from the refrigerator, and now stopping the reaction by adding tris. Once that's complete, she'll be ready to hand off the microtiter plate to Hannah for the array portion of the assay. For the array portion, Hannah first is going to assemble a slide with a gasket that separates the different microarrays. She'll then be able to block it using a milk reagent. After blocking, she will use a multi-channel pipetter to pipette in biotinylated patient samples. After that incubation process goes on in the dark, she will be able to wash the slides and then add streptavidin again with a multi-channel pipetter. After that incubation step and a washing step, she will do a final wash with distilled water, which we'll see in a second. Here she's removing the gasket from the slide carefully to not damage the arrays, dipping the slide in distilled water, and now drying it with clean air. After drying the slide, it will move to our confocal laser scanner. Here she's putting it in a box to prevent light bleaching of the fluorescence reagent. Alexis is now loading the slide into the scanner. It's barcode labeled. Barcodes follow this throughout the entire process. And now the scanner will automatically create an image of the slide, which you can see appearing here with multiple microarrays. Here's the final result of one microarray that will be uploaded to our custom IES software for the generation of decision values and the patient result.